Today we're going to be discussing independent and dependent events. Independent events occur when the occurrence of one event does not affect the probability of the other. They're completely independent of one another. Dependent events occur when the occurrence of one event does affect the probability of the other. We're going to take a look at the formula that we use for the probability of independent events. If A and B are independent, then the probability of both A and B occurring is equal to the probability of event A times the probability of event B. And I think this will become much more evident as to what this means if we look at an example. So let's take a look at this first one. An experiment consists of randomly selecting a marble from a bag, replacing it, and then selecting another marble. The bag contains 3 red marbles and 12 green marbles. What is the probability of selecting a red marble and then a green marble? The key here is that after you select a marble, you put it back in the bag. So if we want to know the probability of selecting a red marble, that would be there are 3 red marbles, and there's a total of 15 marbles in the bag. So 3 out of 15 is the probability of selecting a red marble. Now, as far as the green marbles go, we've taken that red marble, and then we've put it back in the bag. So there's still 15 marbles in the bag. So now we want the probability of selecting a green marble. Well, there are 12 green marbles, and there are still 15 total marbles in the bag. So here are the 2 probabilities. We multiply them together whenever we're talking about independent events. We multiply them, and we end up with 36 over 225, which reduces to 4/25. All right? So there's an example of how you take something out of a bag, you replace it. And so actually your total number of possibilities, notice, remains the same. They stay at 15. Let's look at another example. A coin is flipped 4 times. What is the probability of flipping 4 heads in a row? Well, each coin flip is independent. One flip doesn't have anything to do with the other one. And so the probability of getting heads is 1 out of 2. And it happens 4 times. So you have 1/2, 1/2, 1/2, and 1/2. We multiply all of these together, and we get 1/16 as the probability of flipping 4 heads in a row. Now, we're going to be talking about dependent events. The probability of a dependent event, it says if A and B are dependent events, then the probability of A and B occurring is equal to the probability of event A occurring at times the probability of event B occurring after A has occurred. Now I know that probably sounds confusing. It'll make more sense in this example. A snack cart has 6 bags of pretzels and 10 bags of chips. Grant selects a bag at random, and then Iris selects a bag at random. What is the probability that Grant will select a bag of pretzels and Iris will select a bag of chips? Well, let's think about it. When Grant goes to select his particular snack bag, there are a total of 16 bags of snacks on the cart. He selects a bag of pretzels, and there are 6 of those. So the probability of selecting the bag of pretzels is 6 out of 16. Now he keeps his snack bag, so now there's only 15 bags left on the cart for Iris. So she selects a bag of chips. There were 10 bags of chips on the cart, so the probability of her selecting that bag of chips is 10 out of 15. Her selection depended on Grant's because he took 1 bag of those snacks away. So it actually changed the total she had to choose from. So this is why these events are dependent. And now we go ahead and multiply them. That doesn't change. We're still multiplying. So 6/16 times 10/15 gives us 60 over 240. And we can reduce that to 1/4. So the probability of Grant getting a bag of pretzels and then Iris getting a bag of chips is 1/4. Thank you very much for joining me.